Lesson 5, 2.5, Solving Radical Equations. A radical equation is an equation with at least one radical whose radicand contains a variable. Okay, so for example, if it's the square root of 2x, where the radical only is over the 2, this is not a radical equation. It has to include, so if I have the square root of 4x minus 5 equals 0, this is the radical equation. You can have radical coefficients and still be a linear equation. So a solution to a radical equation is a root of the equation. We say the equation has a real root. When solving a radical equation, we have to remember to, item number 1, identify any restrictions on the variable, and item number 2, identify whether any roots are extraneous, so they don't make sense mathematically, by determining whether or not the values satisfy the original equation. There are lots of different ways to verify. I'm going to show you one way that works every time and is pretty easy, but if you see a different way to verify, like setting one side equal to 0 and analyzing it, that is totally fine too. So let's launch into some examples here. First thing, okay, so example 1, solve each equation, state the restrictions, and verify the solution. First things first, our restrictions, x must be greater than or equal to 0 because the radicand cannot be negative. So let's square both sides here because that's how you undo a square root, is to square it. So then this simply becomes 5x equals 10 squared is 100. That means that x equals 20. So let's verify. And I'm just going to extend this kind of t-chart all the way down so that we can use this for all of the questions. So the square root of 5x, but we determined that x was 20, and the right hand side is 10, because remember we're going to the original equation. Square root of 100 is 10, so left hand side equals right hand side. Woohoo, we're done. What about this next one? Number 1, our spidey senses should be tingling because a square root of some number can never be negative. You can't square root something and get a negative. So for me, when I look at this, I'm like, oh, that doesn't, a solution doesn't exist. Just like if I would say the absolute value of 2x is negative 5. There's just no solution. But let's go through the whole process and we'll see what happens. So in this case, x also has to be greater than 0 because the radicand cannot be negative. So we're going to square both sides. 5x equals the square, negative 10 squared is still 100, same as this. X equals 20. So let's substitute here. What happens? So the square root of 5 times 20, and the right-hand side is negative 10. The square root of 5 times 20 is 100, so that means the square root of 100 is 10. But the right-hand side is negative 10. Left-hand side does not equal right-hand side, so we have to disregard this solution. See, I told you it would all come on the wash. With this one, we're going to state exactly the same thing. X must be greater than or equal to 0 because the radicand cannot be negative. In this situation, we're going to get a fractional answer. So watch and learn, students. Divide both sides by 4. 3 over 4 equals the square root of x. Square both sides. 9 over 16 equals x. Now there's no common factors between those two, so I don't have to simplify any further. So the left-hand side is very simple. It's just 3. The right-hand side is 4 times the square root of x, which we determined to be 9 over 16. So that means 4 times the square root of 9 is 3. The square root of 16 is 4. I'm just going to put this over top. The numerator 4 cancels with the denominator 4, and we are left with 3. So left-hand side equals right-hand side. We're good. Now, these restrictions are a little bit more difficult for these next two, so let's just take a little bit of time with them. So, x plus 1 must be greater than or equal to 0, because the radicand cannot be negative. But let's isolate that 1. So I'm going to subtract x from both sides. That means that, subtract 1 from both sides. So that means that x has to be greater than or equal to negative 1. So if I put in a value of 0, I still get a positive radicand, so that's good. But if I put in a value of, say, negative 2 plus 1 is the square root of negative 1. That won't work out. So in this case, what we want to do is we want to isolate that radical. So I'm going to add 7 to both sides, so 20. Kind of treat the radical as though it's a variable that you want to isolate. Times 2 root x plus 1. I'm going to divide both sides by 2, so 10 equals root x plus 1. Square both sides. 100 equals x plus 1. Subtract 1 from both sides. 99 equals x. Woohoo! So let's verify it. Left-hand side is real easy here. We have 13. And the right-hand side we have 2 times the square root of, well, let me make that a little bit smaller, the square root of 99 plus 1. And that's where my radical ends. It's important to note that it's not the square root of x plus 1 minus 7. It's the square root of x plus 1. And this ends, and then we have minus 7. So sometimes you'll see me kind of like draw it like this, because it's just a little bit more clear as to where the radical ends. But you can just pay attention to this here. And then I'm going to say minus 7. 2 times the square root of 100 minus 7. Square root of 100 is 10, times 2 is 20, minus 7, and that is 13. Left equals right. We are good. Last but not least, first let's talk about for what values of x this can work. So I would say 2x minus 1 must be greater than or equal to 0. We're going to isolate the x. We're going to add 1 to both sides. 2x is greater than or equal to positive 1. Divide by 2. X must be greater than or equal to 1/2. Great. So we're going to isolate the variable again, subtract 5 from both sides. So that's 2x minus 1 equals 12 minus 5, which is 7. Square both sides. 2x minus 1 equals 49. Add 1 to both sides. 2x equals 50. Divide by 2. 25. So I'm going to substitute that in to verify it. Right hand side is real easy. It's just 12. Left hand side is 5 plus the square root of 2 times x, which is 25, minus 1. And then, and then that's it. So 5 plus the square root of 50 minus 1, 5 plus the square root of 49, 5 plus 7, which is 12. Left hand side equals right hand side. Woo!